Exactly right. Here we are, lesson 5.2.5. Nothing over nothing is nothing to worry about. We're going to begin with problem 5-94, piecewise functions and limits. Just extra practice here. Again, if you know how to do this, you will be just fine on the quiz. Given the graph of the piecewise function shown below, complete the following limit statements or state that the limit does not exist. Hopefully we're getting a little bit better at this. Letter A, the limit of f of x as x goes to negative infinity. Negative infinity is this direction. So if we're on this line, we're tracing it towards negative infinity. Where does it appear as though it's going? Some confusion here. Some people might say it's going to eventually go below that x-axis, but it does appear as though it's leveling off a little bit. So the best answer there would be the limit approaches 0. Letter B, what is the limit of f of x as x approaches negative 2? And we're talking about from the left here because of that minus sign. So right here is the vertical plane for negative 2. As we approach it from the left, what y value are we getting closer to? The answer there would be 2. What about approaching negative 2 from the right? That means we're on here on this parabolic portion. Approaching negative 2 from the right. What y value are we approaching? We're approaching the y value of 3. And then the question that ties those two together, the $1 million question, is what is the limit then of negative 2? Well, we've already found the limit from the right and the limit from the left. Do our fingers meet? No, they do not. Therefore, the limit does not exist. Letter E, what is the limit as x approaches 2? Now, we're not going to come from both directions. All right, we're just finding as it approaches from 2. So from the left, from the right, will my fingers meet? Yes, it will. And that value is 3. And then finally, the limit as x goes to infinity. This line here is linear, which means it's constantly decreasing. Therefore, as x goes to infinity, y will go to negative infinity. Hopefully you're getting a little bit better at identifying limit statements and answering them. Problem number 95. Now we're given a graph. Given the graph shown below, come up with 5 limit statements corresponding to this function. Okay, so there's many options here. Okay, we'll say limit of f of x. Okay, and that's going to be the same every time. What changes is what we're approaching. So we can say as x approaches negative infinity. We can do limit of x, of f of x, as x approaches negative 4 is a hot spot. Obviously, we could approach negative 4 from the left or the right. Limit of f of x as x approaches negative 1 is another hot spot on that graph because of the hole in the graph. We could approach negative 1 from the left and from the right. We have the limit of f of x as x approaches 1. Again, another break in the graph. We could approach 1 from the left, we could approach it from the right, which would add 2 more statements. Finally, we could do the limit of f of x as x approaches positive infinity. So there are 5 limit statements that you could use. Obviously, we can add many more by coming from to negative 4 from the left and right, negative 1 from the left and right, and 1 from the left and right. Let's answer these real quick. As we go to negative infinity, what are we approaching? Here we are, we're approaching 0. As we go to negative 4, trace my finger from the left, from the right, I'm actually going to positive infinity. They're both approaching the same value. That's the first time we've seen that with the vertical asymptote. What about approaching negative 1? Negative 1 from the left, from the right, I'm going to the same place, I'm going to positive 1. In this case, approaching 1 from the left, 1 from the right, I do not meet. So the limit does not exist. And finally, approaching negative infinity, it does appear as though this is going to level off. So it might level off at negative 1, it might be a negative a half. Your guess is as good as mine, negative 1 will be sufficient. Problem number 96 talks a little bit about what we talked about in class as far as what happens when we have sine of x over x. Okay, and it does say that it is interesting because the numerator and denominator are both approaching 0. So since, but the limit turned out to be 1. All right, and again, that goes back to Miranda's idea that we had 0 divided by 0, and that's this here is not the important part because we know that's undefined. Okay, the important part is we have a number divided by itself, which we know from elementary math equals 1. Now it does talk a little bit about the unit circle there, and using the unit circle to describe why, reinforce why the limit is going to be 1, and we will discuss that in class. Problem number 97, here's a few more limit problems here with involving trig functions. So letter A, why does the limit of x approaches 0 of cosine of x over x equal infinity? You can answer this by thinking about what happens in the numerator and denominator as x approaches 0. So let's take a look at it. So we have the limit as x goes to 0 of cosine x over x. So again, if I take the same approach, the limit as x goes to 0 of cosine of x, what's that going to equal versus the limit as x approaches 0 of x? What do I get for each of them? Well, for cosine of x, as x goes to 0, think about what the graph of cosine looks like. It appears as though from the left and from the right, I'm approaching the value of 1. The limit of x as x approaches 0, we already did that today, is approaching 0. When I put them together, I have 1 divided by 0. But remember, this is a conceptual thing, not an arithmetic thing. All of you are trained to say 1 divided by 0 is undefined. However, what we're really thinking is we have 1 divided by small. Anytime you have a number divided by something small, you get big, which makes our answer to the original problem infinity. Part B, why does the limit of x divided by 2 to the x equals 0? Again, talk about numerator, denominator separately. I'm going to get a different color here. So we have the limit as x approaches 0 of x divided by 2 to the x. So the limit as x approaches 0 of x is going to equal 0. But the limit as x approaches 0 of 2 to the x, I can use a graph, I can use a table, I can plug 0 in for x, is 1. So here we go. What is 0 divided by 1? This one's not as crucial conceptually here because we know what 0 divided by 1 is. It's not undefined. It gives us a numerical answer. It gives us the answer 0. Again, the conceptual part is not the most important part right now because we're introducing limits. You could always sketch this graph and use the sketch of the graph to determine your limit. You could also use a table and approach the value of 0 from the left and from the right to determine your limit. Both of these are probably the best way for beginners to determine a limit of a function like this. One more problem here, number 98. And again, number 98, we're looking at more trig functions. We have 1 minus cosine of x over x. Question A, what is the domain of this function? It may help us to bring up our graphing calculators. So if you have one at home, take it out. If you don't, you can follow along with mine. Okay. Obviously, there is going to be one value that is not part of this domain. And we know that's going to be 0. So we do know that x will not be able to equals 0 because we can't divide by 0. And again, that has nothing to do with the limit. Okay, but if I do go to my graph, use parentheses around that numerator, 1 minus cosine of x. Make sure I close both sets of parentheses here, divided by x. I can zoom trig that, see what it's going to look like. And it sort of looks like a little bit of a stretched out cosine graph. However, I do believe that it approaches an asymptote on each side. A horizontal asymptote. Okay, here and here. All right, so what is the domain? If we go to the table, you'll see that the 0 value there is not part of this. So it does not exist. So we probably would say for our full domain, all real numbers not equal to 0. I think everything else will work. Should work. What is happening in the numerator and denominator as x goes to 0? So 1 minus cosine of x as x goes to 0. Well, cosine of x is 1. 1 minus 1 is 0. So this should be approaching zero. Okay. Let's take a look at it. 1 minus cosine of x. Graph. So I have an upshift of 1, okay, but it's a negative cosine graph. And you'll notice as x approaches 0 in this graph, I'm also approaching 0. What about the denominator? The limit as x goes to 0 of just x. We've already said numerous times that that's approaching 0. So find the limit of f of x as x approaches 0, the whole function. And we've had our table up before for that particular function. All right, we can throw some parentheses in here to get another picture of it again. And we should be able to see for the entire function, as I'm approaching from the left and I'm approaching from the right, both of those are approaching which particular y value, and in this case, they are approaching the y value of 0. Last, does f of x have a horizontal asymptote as x goes to infinity? And again, that answer would be yes, because it will never cross that x plane there. And another way to determine whether it has an asymptote or not is to think about the end behavior of the graph if you plug infinity in. So regardless, 1 minus cosine, that means you're always subtracting 1 minus a number smaller than 1 going to infinity. And if you divide that by a really big number, infinity, so the 1 minus cosine x, remember, cosine keeps repeating itself. It can never be bigger than 1 or smaller than negative 1. So you're always going to be getting a number between 1 minus 1 is 0, 1 minus negative 1 is 2. So you're always getting a number between 0 and 2. And you're always dividing that number by infinity. So by dividing by a really gigantic number, you're always going to get a number really close to 0. It's always approaching that value no matter how far away you go, which is why we have the horizontal asymptote as x goes to infinity. And I believe that's it.